going. So then Monday we'll have another review day, and then we'll actually start really reviewing, and then have that final, I'll say the final test, the test on the probability next week, 1 week. And that's a short week because on the 4th is week from tomorrow, we don't have any class. All right. And then that following week, I think that's about 2 weeks, a little bit less than 2 weeks, usually a Monday or Tuesday, the last day to drop. I don't think anybody in here, for the most part, has to worry about that. As long as you keep it up, you should be able to do fine. All right, so let's go what I was going to show you in that textbook. All right, so there's two kinds of odds. Odds for something and odds against something happening. I don't know why it's not letting me highlight it, but I'll just highlight it temporarily. So generally the way you write odds in favor is okay, it finally took. Odds in favor is you use the numerator of your success colon numerator of your failure. And then for odds against something happening, you just reverse them. You can see that sometimes people write them differently. They'll write them as fractions sometimes, but I don't like writing up odds as fractions because then it makes it easy to mix it up with a probability. I'll just kind of give you an idea here. See, odds in favor, it's you can see here they calculate it, and I'm going to show you how to calculate in a minute. 1/12, but I said is in order to kind of be safe, write it as 1:12 because you need to make sure that everyone knows that it's an odd and not a probability. And you see the other confusion that can rise. So if you take those and flip them, 12/1 is the odds against, because that's the only difference is you said that they're a mirror image of one another, but then that would be 12/1. So that's just a little caution. All right. Let's try this right here, just as kind of a thing. What we need to do, the first step, to find odds is to get probability of success and probability of failure. That's just two general terms. For this, we would have the probability of having a prime number. And let's see, I'm going to bring up that thing because I don't have that in my head right now. It's too big. Let's bring up the 2 die. All right. Oh, I tell you what, this one's got the sums on it. So this is what comes up on the die, 1/1, and then this is the sum. So this will be good. So what we want to do is just to find all the ones that are prime. And as I had said, is a prime number is one that's only divisible by itself and 1. So 1 doesn't count as a prime number, but that's sum is a prime number. 3 is a prime number because 3 is divisible by no other numbers but 3 and 1, just like 2. But 4 has factors of 2, 4, and 1. So therefore, not 4. But 5 is, because 5 only has itself and 1. Okay. 6 is a composite number because 6, 2, 3, and 1 are all factors, so not 6. But 7 is. 7's a prime number. It's divisible by no other number but 1 and 7. 8's got 8, 2, 4. 9 has 3, 9 and 1. 10 has 2, 5 as factors, as well as 10 and 1. But 11 is the next prime number. 12 is not a prime number because it's divisible by 3, 4, 12, and 1. So how many do we have circled? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 prime numbers. So there are 15 values out of those 36 that sum to be a prime number. All right. So the probability of prime sum is equal to (15) over 36. And we need to simplify these always. All right. So both of those are divisible by 3. So 15 divisible by 3 is 5. 36 divisible by 3 is 12. So 5/12 is what we call the probability of success. That's just a general term. So when we're talking about odds, we know what number is going to come first. So therefore, this right here is our A. That's A. All right? We're not worried about the denominator. The probability of not prime then is going to be the complement. Here's the quick way to find it. And you'll see them doing this. And unless you really catch on quick, you'll wonder why they're doing it. But this is all it is. It's the complement rule, but it's kind of the poor man's complement rule, because we don't need to go through all that with the fractions. We don't have to. We want to try to make things easy here. So 5 from 12 is 7. All right. And just kind of notice that 5 over 12 plus 7 over 12 is equal to 12 over 12 is equal to 1. So that's what I did, is I just found the complement, because otherwise, if you use the the pure complement rule, then you're basically doing 1 minus 5/12, and you find out what that is. But if this is 12 over 12, then 5 minus 12 gives you 7/12. No matter how you do it, you're still going to come up with a complement. So this is the probability right here of what we call failure. All right. Just to give it a general name. So probability of success then, or probability of, let me back up. Odds for is A to B. And I didn't point it out, but this right here is your B. So see, this is this odds right here. What are the odds in favor? Well, it's 5 to 7. So the odds in favor of rolling a prime number are 5 to 7. It's a little bit less than half proportionally. All right. These right here should have no common factor. That's why you simplify these when you do them. Simplify the fractions. Because you do not want this to be something like 5 to 10. You would want to simplify it to 1 to 2. This one didn't need to be simplified because we simplified that fraction, and then that assured us that we weren't going to have to worry about simplifying it at the end. All right, so what do these odds mean? Anybody got a guess? Well, it's not all that complicated. It's just a matter of for 12 rolls on that average, 5 will be prime and 7 will not. So that's what these odds mean. If you do it as odds against, 7 to 5. That's why you have to know which one it is. It's odds for or odds against, because the numbers can be turned around. And see, they use this here. This book gives you a little bit of insight, because they do that complement thing right there. So now what we can also do is we can take any odds. All we need is just to have one of them, and then we can recreate the probability. All right, any questions about that?
So the odds against would be switched, right?
Yeah, let me write it here. 7 to 5. Just flipped around. All right. So they give you these formulas, and like I said, that's really what we just did. All right. With that complement rule, I don't really like those formulas for some reason. I guess they're technically right, but I just never thought of there needing to be a formula for odds in favor and odds against. But again, the problem that I have with it is they show it as a fraction. If they did it like this, it would make a little bit more sense to me. If you did that, it would make a little bit more sense. Because like I said, then it's written like a probability. I'm sorry, like an odds. And then this one here. So see how they're just switched around. All right. Find the next one to do. All right. So this is just a note. If odds are 1 to 1, Actually, it would be anything like 5 to 5 or 10 to 10, but the simplified form is 1 to 1. And what that just simply means is that it's an equal chance to be winning for each side, equal chance at winning and losing. It's called a fair game. All right. So, according to the National Safety Council, the odds. Oh, let's do this one. This is the example, and they just show us. But let's just go through this, since it's one that I can work out the way I like. When two dice are rolled, the odds in favor of getting a 9 are 1 to 8. Okay, 1 to 8. So they're giving us that information. Find the probability of not getting an 8. So what this means is it's odds in favor. So this is A, and this is B. Because that's odds in favor. They're telling us that. So that means the first number is A, the second number is B. All right. The probability of sum 9 is equal to. All right. Now this is going to be where we use that little formula. See how the I know that I need to do one more step after this, but I was going to take you through both parts. So that's the formula for probability of success, or in this case, probability of getting that sum of 9. So that's going to be 1 over 1 plus 8, which is equal to 1/9. And you remember we calculated that, I believe, earlier. Or maybe I got it in the lesson we'll get today. So that's 1/9. Now, here's what they asked for, because what they want is not getting a sum of 9. So what it's going to be is just going to be the B up here. And then we still have the A plus B down there. So that's still going to be 9. Oops. 9 down there. And 1 from 9 is 8. Okay. The complement of 1/9 is 8/9. And like I said, the real quick, cheap, easy way to do it, 1 from 9 is 8. And that's our new denominator. So this is what they wanted. So odds in favor of rolling the sum of 9 is 1/9. Odds against rolling the sum of 9 is, I'm sorry, probability of sum of 9 is 1/9. Probability of not sum of 9 is 8/9. Because they gave us the odds in favor was 1 to 8. And whether they'd given us odds in favor or odds against, we would still have the two numbers we needed. That's all you need is just those two numbers. And then you can add them up to get your denominator, and then use A in the numerator for probability of success, or B in the numerator for probability of failure, which in this case, the probability of failure was not sum of 9. Oh, and this is telling you, this is interesting if you want to read it. I don't know. It's not really necessary for the class, but it just talks about how lotteries, and not just in lotteries, but any kind of gambling, you got to watch what the payout is. And they give you two scenarios, one with roulette and the other with the state lottery. All right, so expected value is the other thing that's in this lesson. Expected value is a way to quantify, usually by one number, what the outcome will be for doing a particular event or game multiple times. We can never predict what's going to happen on one roll of the die, but we know that if we roll it continually over and over, then we're going to have a certain outcome that we can expect. That's why it's called expected value. All right. So what expected value amounts to is we take what we expect to happen for doing a particular for each one of the scenarios in the game, because there's going to be several outcomes, and we multiply those outcomes down the times the probability of them happening. And when we multiply what we expect to get by the probability, and then we add them all up, that tells us what's going to happen on the long run, what we could expect if we do this many, many times. All right. All right. I guess we'll work on this one. For some reason, this one bothers me, but if we got a good picture, maybe it'll be all right. And we got to get an American roulette one because it's different in Europe. And I think what it amounts to is in Europe, they've got one house number, the green. That's what the house number is. And in America, they have two greens. All right. So we've got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. There are 38 numbers on the roulette wheel. 2 of them are green, obviously. So that leaves 36. Half of the 36, or 18, are black, and half of the 36, the remaining 18, are red. So that's what we're using, that information here. So let's go back over here. All right, on a roulette wheel, there are 18 slots. I mean, 38 slots, 18 of which are colored red If you bet $5 on a red and win, you get $10 back. If the red doesn't come up, you lose your $5. So this is important to understand for expected value, because you got to understand exactly what you're netting as far as your number is concerned. For roulette, if you put down that $5 and as a bet and you lose, well, your $5 is gone. If you win, well, you just don't lose your $5, but you get $10. All right. I don't think they're going to let me copy that. All right. So I want to put it somewhere else. All right. So let's just go over here and find a nice. All right. It was red, wasn't it? Oh, it's just saying find the expected value. Okay. So what I like to do with expected value is just draw a little chart. It usually helps to do this, just because it organizes things. You can do it without it, but one of the things that I've learned is an organized way usually make things a little bit better. All right. So there's what possibilities do we have with roulette? I mean, if someone's betting on a particular number, all right. I don't think we need that many thingamajigs though. All right. So the first thing, we're going to have X here, which is the outcome. All right. I think we just need win and lose. I got this in my notes. I don't know why. I can't remember exactly how I got it set up, because usually over time I set things up the most efficient way I can think of. All right. So for winning, so if you win, so the probability of winning is 18 over 38. I'm going to put that probability in first. Now, the complement of that, in other words, 18 from 38 is 20. So the way the American roulette wheel works is 38 slots, and you got those two green. So the two green are added. It's not a fair game because the lose is not 18. You got two extra over there. Now, if you win, you get $10. If you lose, well, you lose $5. So that's why I'm making it negative. $10 plus, $5 minus. Now, what we're going to do is we're going to multiply these. So our expected value So what we're going to do is we're going to multiply each of these. We're going to take 10. Let me put it down here so I don't have to stay in those little blocks. Expected value of X is equal to 10 times the 18 over 38 plus, or minus in this case, since it's negative, 5 times 20 over 38. So let me come in and write that back in. I don't like those fractions like that. All right. Let me try that again. So 10, I'll put it in parentheses. That's what I'll do. So 18 over 38. And notice that I'm leaving the fractions unsimplified. That's going to make it easier to add these up if we keep that same denominator. Now, when we multiply fractions, we talked about this a little bit before, but if we multiply fractions, let's say we have 2/7 times 3/4. Then we multiply here and here. So it would be 6 over 28 or 3/14. And incidentally, I could have simplified here first. And then I would have had the simplified version. So if you simplify your fractions first when you're multiplying, it makes the outcome easier. But it's still 3/14 because it would have been 7 times 2. All right, but what happens if we multiply a whole number times a fraction? All right, so let's say we got 25 times 1/5. Well, what that means is that whole number can be written as a fraction. And then so when we multiply, that whole number only multiplies the numerator. So 5 goes in there 5 times. So we end up with 5 over 1 or 5. We just generally don't write a whole number with its denominator because it's just kind of redundant. It's the base case. And usually for the base case, we don't put anything other than just a 5. But what this means is this is 10 over 1 times 18 over 38 minus 5 over 1 times 20 over 38. All right. And then here we can 1 and 18, no common factors, but here both of these are divisible by 2. And this would be 19. So then we got 5 over 1 times 18 over 19 now. And that's an equivalent multiplication. Minus Here, the only thing we can simplify is this one because they're both even. So cut them in half. So that would be 10 over 19. All right. So we're going to multiply here. So 5 times 18. Five times 18 is going to be 90. And notice we keep our same denominator. And that's what we want because we're going to make one subtraction here. And 5 times 10 is 50. And that's over 19. Something's bothering me about this. I don't know what it is. But the process is generally right. I made this. So you win $10, you lose $5. Let me double check something that I did that simplification right. Oh, 180 divided by
So, Mr. Cruz, when you cross multiplied the 5/1 times the 20/38, how'd you got that?
I didn't. I just simplified this one.
Okay.
The sum's not right. Let me go back and see what I did. I usually do all these kind of things, and I mean, I can't really introduce this to you because, for the tests, you can't use any outside stuff. Like I like to use a spreadsheet to do this. It makes it so much easier. But plus, also talking about, let's see, so I'm going to just do one thing real quick. I feel like I messed something up over there. So I'm just going to do this without the simplification. So 10 times 18 is 180 over 38. Minus 5 times 20 is 200. Now this one's right. Okay. So I don't know what I did over there. We can go back over there and find it. So this is going to be 180 minus 200 would be negative 20 over 38. And now it doesn't matter what we've done up to that point because generally what they want for expected value is to give it as a simplified fraction or generally as decimal, because oftentimes what you're dealing with in expected value is money.
So I got 100 over 38 because 5 times 20.
Hold on a second. Let me finish this. I just got one more step. And then I'll see what you get. Because I know I messed up on that side, but this should be right. So negative 50. So we round off to 2 because it's money. So 0. So what this is 53 cents negative. All right. So what this expected value means is and then I'll come back and see what I did wrong here. I just wanted to. I was just being a little bit too fancy over there and simplifying them first because I did give you that advice. But for these, you do need to have the same fraction denominator and denominating your fraction to add them. And I think I messed something over there. So what this means is, if we play this roulette over and over and over again, and as far as the house is concerned, then every time somebody spins this wheel and bets on red or black, it wouldn't matter because it's an equal. They're both the same. You will lose 53 cents. The player will lose 53 cents. Now, it's not possible if they play $5 to lose 53 cents because you're either going to win $10 or you're going to lose $5. But on the average, as bunches and bunches and bunches and bunches of people play, the house can expect everyone to lose 53 cents a roll. All right, let's see what I did over here. Like I said, in theory, it should have worked. So 2 goes into 10 5 times, 38, 19 times. And that's right, 5 times 19. This is not, yeah, that's 50. I don't know. I guess I'm just going to have to.
No, so
must have done
for the
something.
5/1 times 20/38, I did 20 times 5 is 100.
Which
Over
one? Over here?
the 5/1 times 20/38. 5 times
So
20
that's 100. Okay, that's what it is. All right. That's what I did. All right. So thanks. That's what it is. No.
No, I'm saying so to the right where you got the
Oh, wait a second. I know what it is.
3 cents.
Well,
Yeah.
I'm just see, the problem here is this one's smaller. The negative one is smaller than the big one, so it's going to give us a wrong expected value because it's going to be positive. So I don't even know what I did wrong here.
Yeah, I didn't
may have to do this.
simplify.
Yeah, let's just take the simplification out. So for the expected value, don't simplify until the end. And they even tell you that, although that's not the problem here. I just got a boneheaded mistake in there by. So let's just put it back to being the original, and then we'll come over here in the blue. So 10 times 18 is 180. 1 times 38 is 38. The negative sign comes over. 5 times 20 is, oh, wait a second. That's 100. Is that what you were talking about?
Yeah.
All right. There we go. That's what you were talking about. I got you. All right. So this is going to be then it's not positive then if that's the case. All right, let's just do it. I'll do that one later and figure it out. I don't want to spend I wanted to do something that just spend a lot of time and actually get through one. But that's the general procedure. You're going to find out what you get times the probability, and then there's win and lose. Because there's no in between on here. There's no nothing. It's either you lose $5 or you win $10. And more often you're going to win. Let me just do something. One of the things that I like to do, like I said, I like to use a spreadsheet sometime to just double check. It's just that you're not going to be able to do this on the test, so I hate to bring it up. And then that way I'll be able to tell if I got it set up wrong. You don't have to know how to use a spreadsheet. I'm just going to check. The reason why I like spreadsheets better than calculators. And as a matter of fact, I used to actually teach using the spreadsheet, but the department wants everybody to be on the same page and all that. All right, I'm going to think about that one, man. Let's go to find it or another one. I don't know what this is what I get for being spontaneous. Obviously something's in there isn't that right. Let's find one. Let's find us a good expected value problem. I've done that problem so many different times. I don't know why I'm drawing a blank on it. Let's see. All right, let's look at this one that's in blue. At this year's state fair, there was a dice rolling game. If you rolled 2 dice and got a sum of 2 or 12, you won $20. If you rolled a 7, you won $5. Any other roll was a loss. It cost $3 to play the game. All right, so I'll come back to that problem. I'm just going to draw us a little chart because there's not enough room. So I believe there's like, okay. At this year's state fair, there's actually, if you rolled a 2, if you got a 2 dice, you got a sum of 2 or 12. 2 or 12. All right, now let's see how many sums of 2 or 12 there are. We got our little thing here somewhere. All right, so there's only 2 of those. So the probability of winning on 2 or 12 is 2 out of 36. So this right here will be the X. We're going to come back to that. And then this will be the probability of X. So that's an X. All right, so it's 2 out of 36. And then what happens if we get 2 or 12, we win $20. Now, here's where we got to watch out. This is your paying to play, okay? You don't get that money back. You're buying a ticket and then they're pulling it, all right? It's different with roulette. Roulette, the $5 stays there on the table. If you lose, they take it. If you win, you get to take it back and the winnings. But you win $20, but you pay $3. Okay? So this is the $20 here. But the winning part is 17. All right? What was the other one? If you roll a 7, you win $5. And it's not $5, it's $5 minus 3. If you roll a 7, you get $5, so it's going to be $3. All right?
Wait, why is it 3?
Because you're paying, it's $2, isn't it? Right?
I don't know. I don't know what.
Okay. You win $5 for rolling a 7. See this? You roll a 7, you win $5. But because you're paying $3 to play, you're only getting $2 ahead, okay? Any other? Okay, we got to find out how many sums of 7 there are. There's a bunch of those. 1, 2, 3, 4, 5, 6 of them. 1, 2, 3, 4, 5, 6. So then 6 over 36. And then any other. So this right here is the $5. And then this right here is just lose $3. Okay. And that's going to be minus 3 right here too. And that's other. Well, that's what did it say lose? And now 6 and 8. 6 and 2 is 8. So those right there are the only winners. There's 8 winners. 36 is 28. So 28 losers in that set of dice. 6 will win you the $2 net, and 2 of them will win you the $17 net. All right, now we're just going to multiply across. So let me put another line. So this is the expected value line. So this right here is our EX. Because we're going to add all these up. So this is 17 over 1 times 2 over 36. This is 2 over 1. Times 6 over 36. Because remember, there's 6 out of the 36 that are 7s. And then here, negative 3 over 1. 28 over 36. And I'm keeping them all the same. That's really what I should have done on that last one. I think that's where I messed up, but I need to go back and look at it. All right. So then this is going to be here simply 17 times 2 is 34. 36 down at the bottom stays because it's just been multiplied by 1. 2 times 6 is 12. Keeping the 36. Minus, and what is 28 times 3 would be negative 84. So all of these have the same denominator. So all we got to do is just add the numerators. So let's see what that numerator comes out to. All right. 34 plus 12, 46 minus the 84. So this right here is minus 38 over 36. And this one is right because, like I said, I remember doing this one before. So now we're just going to take that 38 and divide it by 36. And this would be $1.06. So the tickets cost $3. So that's why we only get $17 and $2 for those 2 winning rolls. But on the average, this is like a game, like I don't know if you think of it as a charity benefit or a gambling game. It doesn't matter because these rules still apply. The probability still applies. So for every ticket that's bought, $1.06 is going into the pocket of the person hosting the game. In other words, 1 ticket loses $1.06. All right. Well, I'm gonna stop there and give myself a little extra rest because I want to go back through that problem and see if I can figure it out. And I'm gonna do. I got one like that in my notes. I may do the same one again, but I hate leaving something on there unfinished. But I'm gonna cut out a little bit early. If you don't have any questions, I'll stick around until y'all all gone, and then I'll come back at 12:30 and I'll give the formal presentation of this stuff from my notes. All right. I'll see if I can figure out that one that I messed up.
Okay, thank you.
Okay.
Yeah.
Okay, thank you. See you in a bit.
Okay. See you in a little bit.